Welcome, everyone. Thank you for joining us today for this keynote, Scaling Spinnaker in the Multi-Cloud and Multi-Region SaaS Deployments. My name is Gopinath Rebala. I am a co-founder and CTO of OpsMx. I am joined here today with Edgar Magana. He is a Salesforce senior architect who's driving the adoption and implementation of the Spinnaker at Salesforce. We have seen the Spinnaker adoption tremendously increase over the last few years. And with that, the scale of the deployments have also increased and the challenges that came with it. So we addressed some of these challenges before. And today what we will do is we'll talk about the journey at the Salesforce, how they are overcome their challenges and how they're doing the deployments today, what their architecture is, and what challenges remain. To that, let me welcome Edgar Magana to give us his view on the journey and where they are today.
Thanks so much, Gopi. Hi, everybody. It's an honor to be here in the keynote for the Spinnaker Summit. I missed you all last year in San Diego. We have a lot of fun, and well, circumstances are a little bit different this time, but we got the opportunity to get together and let's enjoy the most of it. So today we're going to talk about what's going to be the journey for Spinnaker at Salesforce. We have a multi-cloud, multi-regions, software as a service deployment. So let's talk about that and the challenges that we're facing in this journey. So we adopted the Spinnaker a little bit over 2 years. It started as everything, a POC, understanding the open source platform, understanding the capabilities, the challenges. And right now, as we mentioned before, we are in multi-regions. We have production system running, and Spinnaker is actually the mechanism to deliver all those applications into the cloud. So let's talk about like what it is today, Spinnaker at Salesforce. So first of all, we have a clear separation between what it is the prod and the non-prod levels. We got two main Spinnaker, one controlling all the deployments for the prod level, and another one that is for the pre-prod, non-prod level of these environments. We have multiple environments. They go across multiple regions. I can mention like almost all of those regions are, share in these environments. We have all the prod environments and the stage environments where our customers are already accessing their applications through the mechanisms that we provide them to our internal customers to make patches, roll out upgrades, keep things up and running with operational excellence. Non-prod environments are way larger because they provide all the test environments, or the development environments, the performance environments, everything that the development team needs to actually develop, test, and build all the confidence to promote those artifacts into the production level, and then Spinnaker will take over and roll out those changes. So for those Spinnaker instances, let's start with the pre-prod one. As I mentioned before, is the larger one. We have around 1,800 provider accounts. So Cloud Driver needs to load all those accounts. We're going to talk about that. 80% of those accounts are Kubernetes accounts. In terms of applications, we have around 1,754 the last time that I checked, just before this session, actually. In terms of pipelines, we have over 100,000 pipelines. That reflects the number of environments that we are deploying the same application, and all the different stages and pipelines and a single application will cover just to reliable deliver all those services into the cloud. And obviously execution is another vector that it just keeps growing, right? We have over 800,000 executions in the non-prod, and that's because 4 months ago we had to do some tuning into the database, so we purge a lot of executions, and it never stops. Our Spinnaker instance, they just constantly running pipelines, executions, they never stop. It's just amazing how much it works. Prod's a little bit smaller. We have around 500 provider accounts, 80% again, the same rates with the Kubernetes accounts. And in terms of applications, it's very close, just because in the pre-prod we have way more testing applications. People just create their own applications, but in general, it's the same amount of applications that we have in both of them. In terms of pipelines, we have 54,000. That means we have less production environments than development environments. That makes sense. And executions, we go over 1 million because it's been running for the 10 months, and the rate for pushing is lower than the pre-prod one. Now, in terms of our architecture, we tried first fault tolerance, right? So right now, all our services are backed up by some kind of SQL. So for our deployments in GCP, we have from 50 Cloud Driver, Echo, and Orca, all behind a Cloud SQL. We have replicas for all the microservices. We have our Redis connected to a persistent volume, so we actually keep things at as stable as possible. We actually were investigating whether we want to migrate our Redis pod into as a service like Memcache or something like that. So that's kind of like work in progress. But in general, this is giving us a lot of fault tolerance for the Spinnaker instance. For our AWS deployment, so very similar here. I'm adding a couple of things that are complemented from the previous one, which is OutC, OutN. So we have also MTLS that we're going to be covered for all the microservices. Our endpoints, Gate and Deck, they have TLS and the same configuration, right? From 50 Cloud Driver, Orca, all of them they go behind on a SQL database, which in this case is RDS multi-region. And this is an EKS cluster, so it gives a lot of flexibility, and we can keep our own AMIs with the patches that we want. So that's a very high level our architecture. Talking about like the challenges, right? So the non-prod, which is the biggest one, the Spinnaker deploy instance goes to all these multiple environments. So we have, breaking down 600 accounts for the first dev environment, then 100 accounts for the second dev environment, and so on, right? So we have so many dev environments and so many perf tests in general. You can imagine the scale of Salesforce and the level of customers that we have. So we really need to have all these environments and those accounts. And we have only one Spinnaker, right, for all this kind of work. We're thinking about like a DR environment. So it's going to be a clone of the Spinnaker deploy. It's going to have the same services, and we're going to use some kind of global DNS configuration to actually switch one to another. We're preparing some white papers or blogs about how we're going to achieve DR. So probably for the next summit or something like that, we're going to be able to disclaim all our work around that. But here the point is, I was mentioning about 800 accounts, right? 1,800 accounts. Right now, for whoever is familiar with Cloud Driver, you know that caching all those accounts, making sure that Cloud Driver is going to be up and running, it takes, in our case, over 70 minutes. And that's going to be the case for everybody, right? That's not essential, right? You can make Cloud Driver HA with read-only, read-write specific instances, but still, it's a very heavy system and it caches a lot of information. When we have to create new clusters specifically for the Kubernetes, and we dynamically add those accounts, we were expecting that their account is just really added and it's just caching the extra resources from that new account, but that doesn't happen. It just recache all the data. It takes over 100 minutes to actually have that new account up and ready, and actually Cloud Driver will be able to talk to that Kubernetes cluster and to do anything for that one. So here is our biggest pain. We can have our customers waiting for a couple hours since they have the Kubernetes cluster created and just waiting for start deploying applications, especially because in the non-prod environments, we destroy and recreate a lot of things. We just like to do that because we like to test our automation over and over and over. So it's a big impact in the productivity for our developers, and we are really committed to make this better. So in a nutshell, some of the biggest challenges that we have at Salesforce is adding dynamic accounts. The Kubernetes accounts, it's very slow. We cannot have that problem. I was talking about the number of pipelines. The number of pipelines is just going to keep growing. And we actually don't let users to just modify the pipelines the way they want it. We just use templates and everything is in source code. So we have a pipeline generation process, and that generation process is taking a lot of time because it's talking to the API. And the way it talks to the API right now, it's in some cases very slow. We're talking about all those 1,000 applications to be updated. It takes a lot of time. Resource consumption, obviously, Cloud Driver is all the way to the roof. The same for Orca because it's getting a lot of execution. And when we have mostly applications with large number of pipelines, we're talking about like 100. We have an application with almost 500 pipelines. That's impossible to display it in the UI. It just takes forever. We have to actually remove the gate timeouts just to tell the customer you have a trade-off. You wait and it will come up, or you select the specific pipeline executions that you want to see, and that's going to make things better, right? So we're playing the trade-off with our customers, but that's not the best scenario. We really need some kind of pagination or a better way to display all those executions for large number of pipelines in a single application. Well, I think I talk about a lot of problems, but also how great is growing our CV strategy at Salesforce. So I think that's a moment that we can talk about solutions. And for that, I'm going to stop and I'm going to pass the ball to the smart person in the room, which is Gopi, and he will take it from here.
So we talked about great performance improvements that were done in the Spinnaker. I would like to acknowledge Eric and Maggie, particularly in the Kubernetes front, how they identified what the limitations are and made great improvements in getting the performance through. We will address some of the problems that Edgar mentioned. We are actually working on most of them to address those. We also have other customers that have similar problems, particularly Cisco, which has a great big scale like Salesforce that gets into these kind of issues. So before getting into the problems and the solutions, there are a bunch of features that already exist in Spinnaker that we can use to improve the performance. There were a few things that were already done in the last year or so, which is when you have a large number of accounts, the lazy validation of these accounts. So previously it used to have validation of individual namespaces before the account is loaded. Now those are done in a lazy way. And the amount of data that's being stored for each one of these deployments for caching that has been improved. And there is work that's going on to improve that performance even further. And the Redis usage itself has changed, and you can even have multiple Redis instances to improve the performance and all that. So before that, I just also want to touch on this feature of Cloud Driver that you can use to improve your performance depending on the features. So this is an interesting one, primarily because you can use this feature set to reduce your footprint. So it's like a feature flag that you can set where you say, I don't really want to do the application management. So the Cloud Driver caching, if you look at it, its primary responsibility is to keep the target environment state in memory. So it's available for you at any time when you want to see what the current state is or do the diagnostics. So if for the people who want to do application management, you can use the state to scale the deployment up, scale it down, or even delete the deployment from the UI itself, from the infrastructure tab. It's not recommended, and we don't want people to be doing that. But the second feature that it provides is the diagnostic capability, where you can have your target deployments, pick up the pods, and look at the current logs for it. That's a pretty cool feature, very useful, everybody uses it. However, if we can convert that, getting the logs into a live thing, then if you don't really care for the application management, you can have a feature flag that turn off the caching and have only Cloud Driver RW and Cloud Driver RO running in your system that orchestrate your delivery. You can have every other feature available for you in your delivery pipeline, and can have a lean Spinnaker that's available for you for deployment. It's just an option for some of the customers who are looking for, some of the people who are looking for small deployments with the lean Spinnaker deployment, but they want to scale for the large number of target accounts. So where is the performance really being used? Right? Where are the resources being used? To understand that, we had to see how the cloud driver does the caching and how it manages the target environments. Particularly for this RBAC, the target namespaces and their in the clusters, they are formed into accounts, and each account has its own RBAC that's specified. So for each one of these accounts, there are agents that run that work against those accounts. So for the caching threads, these are the threads that run per account namespace. And as you grow the accounts linearly, the number of caching threads also grow linearly. So as you can see, this is something that runs periodically. So all these threads are active most of the time once you start hitting some number of accounts, and that is where the resource utilization comes in. Now that we understand that, we can also see what it takes for your deployment to scale properly with your accounts. Let's say you have 1,000 accounts, and each account has 2 namespaces. So now what we are looking at is 2,000 of these threads that are running, that are caching the system. Now, given that you have 4 core, you can only run 1 thread at a time, really, on 1 core. And let's say it takes about 1 second to get the data back. Then it's a quick calculation to say, for 1,000 accounts, you would need 250 seconds to cache the entire target environment. So if you scale it to 10 instances, then you would need 25 seconds. So typically, you'd want this target environment state to be available to you all the time, so you can have 10 instances that spread over multiple servers that keeps your state. Now, what is the problem with this? There's one trick here that causes a problem in the memory utilization. So the way it works is, if we scale the number of cloud driver instances, each of these instances is aware of all the accounts. Now, let's say we scale it to 4 instances and you have 1,000 accounts. Each of these instances is going to be managing all 1,000 accounts. At any given time, they are each one of the target environment will only be run once within a given time period. For example, every 30 seconds we want to cache it. Let's say there is a namespace 1 that gets run only once within that 30-second period in one of the instances. But in the next cycle, that can be assigned to a different instance. So in effect, the same namespace can be cached by any of the cloud driver instances. So the memory utilization or cache, the local cache the cloud driver keeps for that namespace exists on all of those cloud drivers at some point. So how do we solve that? Well, one of the simple ways to think about it is, what if we restrict the accounts to an instance? Let's say we bring up 4 instances, and then the sharding rules can be flexible, of course. You can have the sharding done based on your application or account type or cluster or subgroup of the cluster, any of those you can do. Let's say we equally distribute them across all these 4 instances, and each of these instances is doing 250 of those accounts. Then you can restrict the namespace caching to only 1 of the cloud driver, and then you can restrict the amount of memory utilization for that cloud driver. So you may ask, is that really true? Is that how it works? Here we are considering the cloud driver is not broken down into RW, RO mode. It will be true even if you break it down into those kind of modes. In fact, you can take only the cloud driver caching and break it up in this fashion, and you will get the advantages. So because the cloud driver RO and cloud driver RW take very little resources, really. Only when some pipeline is in execution mode, you have the load on those 2. Other times they are pretty quiet. Yeah. So Here is the graph that we have done by sharding the accounts in the cloud driver. So we have 3 instances that are running, and I think we have about 700 accounts that are being used here. The top graph is the one where we have 3 instances for the same 700 accounts. And the bottom graph is where we have this 3 instances which have sharded. And you can see that the ones when we shard, they stabilize around 3 gig of RAM usage. However, the ones that we haven't sharded, there are 3 instances, everything else is the same. They actually have about 9 gig. So as you can see, we reduce the amount of utilization, total utilization, by 3 times. So simply with the existing features of Spinnaker and the cloud driver, by understanding how we can shard them. Of course, there is a complexity in how do we shard these accounts, how do you manage them, those things all exist, but as a feature set, it does exist in today's Spinnaker that we can take advantage of for improving the performance. The other issue with the cloud driver here we were talking about is the loading time. So as the number of accounts increase, the amount of time it takes to load individual account linearly increases. So if you have just 100 accounts, it takes about, say, 100 milliseconds to load an account. But if you have 700 accounts, it takes about 2,000 milliseconds to load a single account on average. So this problem is coming primarily because of the way Spring Boot is dealing with properties and how it's loading from Spring Cloud Framework. So we looked into this problem. If we can eliminate the way the Spring is comparing these properties and loading them, we can tremendously improve the performance. In fact, we've done experiments where we could load 1,000 accounts in less than a minute. Whereas if we go with the Spring approach, it almost takes up to an hour or more to load those number of accounts. And we cannot increase that performance simply by allocating resources to the server. And let's say you run that on a 64 core and 1 terabyte machine, it's going to be very similar to the performance you would run it on a 2 core with 4 GB machine because of the way it loads the thing. So there are simple performance improvements that we can get by doing small changes. And these are some of the things that we are currently working on in conjunction with Salesforce to get them into the community. These are a snippet of a small snippet of the changes that we are making in a very short term. There are a bunch of other things that are going on in parallel that we are working on with Salesforce and ourselves. And of course, in the next 2 to 3 weeks, you will also see so many other performance improvements and also new features that are coming to Spinnaker through this summit talks. And we are also excited to know what others are doing and how they are approaching the Spinnaker in operations as well as the deployment features that implement themselves. So some of the things that we just talked about are sharding or caching to improve the performance, improving the performance of loading dynamic accounts. Edgar also mentioned about bulk updates of pipelines. So if you're changing the pipeline configuration when you're saving them, it takes a long time to save a large number of them. So improving performance there. And fiat is also becomes a bottleneck depending on the number of accounts you have and how the RBAC is set up. So that's another place that we are working on to improve the performance. So from that, let me hand over to Edgar and see if he has any closing comments. We are definitely excited to be here at the summit and over the next 3 weeks. Like you to join with us and also participate in other sessions there.
Well, thank you. That was great, Gopi. So like a summary, right? We're gonna divide and conquer, like the sharding. We're gonna improve the performance of Cloud Driver by removing the Spring Boot or overwritings. We're gonna talk about bulk APIs because we're talking about like very large number of applications and a very large number of pipelines for those applications. So we need to have a bulk API to actually override or update JSON files for those ones. And we're going to talk about like that fiat interaction, right? Probably most of the people in the summit, they are experiencing some bottlenecks with fiat. And I think we're very excited about this. One of the reasons why we wanted to present it to the community is because we want to hear feedback. We want to hear about collaboration. We talk about this in different forums. We're going to talk about this in the obviously Kubernetes V2 SIG. We're going to talk about in the Ops SIG. And we would like to invite the community to help us to drive these changes. Everybody that I spoke in the past, they have problems with the very large number of accounts. It seems like it's a very common problem. This is a solution we really have excited about. This multiple solution, actually, it's just not one. And again, this is an open invitation for the community to help us to get to as soon as possible in a better shape with scaling Spinnaker. With that, we're gonna be in the side chat answering questions. You can reach out via email, Twitter, LinkedIn, whatever you wanna feel comfortable with it. I really like to engage with community. Any kind of suggestions. I wish we were in person and we can actually have happy hour tonight and discuss about this, but we just got to adapt to the new circumstances, the new normal. But again, the community keeps going on, the work keeps going on, and super excited for the next phase for these performance improvements. Gopi, from your side, any closing remarks?
Thank you, Edgar. So that's great. I would love to get go catch a beer in the evening sometime. We do have outdoor restaurants now open. One of the things we'd like to also point out is scaling Spinnaker is not just about scaling to larger sizes and larger deployments, but we also need to make that accessible to quick startup and smaller deployments. So that's one of the things that you will see over the next few weeks, how Spinnaker is doing that. And let's I'd love to work with the community. Please reach out, like Edgar said. Any questions, we will be giving this back to the community, all these changes, and we'll be working with you.
Awesome. Well, we're almost on the top of the 30 minutes that we have. Again, this is a collaboration effort. Everything is going upstream. Help us with reviews, feedback, contributions. Looking forward. Thank you so much, everybody.